Hey guys, so this assignment was for you to solve for the variable, and we're solving exponential and logarithmic equations, and I'll be breaking this down into separate videos and I'll do a few examples at a time. So for this first video, I'm just going to work on numbers 1 through 8. If you ask someone who is in a math class where they're further ahead of where we are in regards to logarithmic and exponential equations, they're going to show you some different ways of solving. We are still in a place where I'm showing you the most raw and original, simple, broken down way to solving these. In the case of example 1, we have 2 to the x power equals 243. If we wanted to solve for x, first thing is you want to make sure that you have the base to a power isolated. And in example 1, it's already isolated. The next thing we do is implement the inverse operation. If I'm working with the base of 2 raised to the x, that's what we call an exponential expression. There's no equal sign, so I shouldn't say equation. This is an exponential expression. To clean up an exponential expression, we use the inverse. Now, for those of you who are using natural log, that's because somebody else showed you that. I did not show you to use natural log. All I had you do in the lesson is take whatever that base is of the exponential and use log with that exact same base, and we're good to go. So I'm going to take a log base 2 of both sides. This will be for the left, equals, and then log base 2, this will be for the right. The left side is 2 to the x. And the right side is 243. Log base 2 of 2 to the x, we can, in a very simple type of way, think of them as crossing out. Adios, gone. All we're left with is x. That's also really the power property at play. That x, because of the power property, can come out front. And log base 2 of 2 is a rule that you could have memorized. It equals 1. 2 to what power is 2? The first, 1. So then you'll end up with x times 1, and that's the same thing as x. So the shortcut way is when you have log base 2 of 2, it just crosses out, and then you're left with the exponent. That's what I showed you in the lesson. On the right, I just have log base 2 of 243. I could ask myself, 2 to what power is 243, but there is no simple answer. The answer is not a whole number. So you're done. I did not show you to do anything else. A future lesson will be change of base property. I will show you how to punch something like this into a calculator. But for now, that's it. You're done. You don't need to do more than that. Let's look at example 2. Example 2 is really the exact same thing, but my exponent is just going to be more than just a variable. It's an expression with 2 terms. The base is 4. If you used log base 2 to do this question, again, someone else showed you that. I never showed you to do that. Our lesson, we said, if we're working with 4 to the n minus 2, the base of that exponential expression is 4. I didn't ask you to ever use a log base 2 to solve something like this. In the lesson, in the examples, if you followed that lead, you would use a log with the base of whatever the base of the exponential is. That's like if you have x to the 3rd power equals 81. I would show you to take the cube root of both sides. However, if you came along and you're like, I'm going to do something different, she gave us x to the 3rd, and I'm going to take the 6th root of both sides. Okay, but I didn't show you that. And you're not necessarily making your life any easier by doing that. You're not necessarily wrong. You'll get the square root of x equals whatever that simplifies to, but that's not what I asked you to do. So that's why when I was looking over your work that you had done for some of these examples, I got a little concerned. So don't seek out help from other places. Not that that's a bad thing. It's great. Seek out help all the time. But if you realize that someone is showing you something that you didn't learn yet, definitely just reach out to me, okay? Or look back at the lesson. I'm going to take log base 4 of each side. Less is more. And let's just draw a little boundary over here. If I take log base 4 of each side, my left side was 4 to the n minus 2, and the right was 3. again, I could just kind of think of it this way. I'm left with n minus 2 equals, nothing to see here, folks. 4 to what power is 3? Can't do it. So guess what I'm going to do? Leave it. You're done with this. Okay? This is great, just the way it is. Last step is to just add 2 to both sides. Another place people were messing up. When you add 2 to both sides, 3 and 2 cannot combine. Log base 4 of 3 is a whole little package deal. That's together. So your answer is n equals log base 4. The 4 is a little subscript. 3 is the same size as the log. Plus 2, or we could reverse it and put that positive 2 in front. 2 plus. Some people accidentally multiplied and just put it in front of the log. So watch out for that as well. It's not multiplication, it is addition. Plus log base 4 of 3. And that is all we had to do. So draw a little happy cloud around my answer, and that's it. Okay? Hopefully we can fix some mistakes based on what I'm showing you now. These two examples are logarithmic examples. They are not exponential. And the whole point of the past few lessons is really figuring out what is the inverse operation and how can I use that to help me solve my equation for my variable. What is the base of log when nothing's there? This question keeps popping up. People still are writing 1 or 0. It's actually 10. When log is by itself, it's called the common log. We want log written alone. If you want to solve a logarithmic equation, you want something that looks like this. Log base b of x is y. Now, that doesn't mean this has to be an x alone. That doesn't mean that this is a y and a b. There are numbers that are going to fill in. These are arbitrary placeholders. So I do have a little invisible 10 down over here, and this 3x is all on the right side of log. There is a difference if you were to have something that looked like this, 3 log x. With power property, you can make that log of x to the third. However, that's not what this is. You could break this apart if you were doing something else. If you wanted to make this into 2 separate expressions using product property, you could. Log 3 plus log x. But again, when we're solving, we want a single logarithm if we could help it. So that doesn't mean that you would be, wrong if you did this. You could definitely solve this way. And you know what? I could even show you a way to do this. Let me just make some room so I can come back to this later and show you a bit. So I will revisit that in a second. So if I go over here and I have log base b of x equals y, that is logarithmic form. And the exponential form of a logarithm was b to the y equals x. That's from one of our first lessons. I think I called it 3.1. So that's what I'm going to do here. I'm going to change that up into that form. b 10 to the y 2 equals x, which is the thing you're taking the log of, or in this case, 3x. And from here, easy breezy, we're going to solve for x. 10 to the second is 100. 100 equals 3x. To get x isolated, we're going to use another inverse operation, division. We're going to divide by 3. 3 and 3 reduce to 1, and you're just left, I'm going to write the x on the left side, with x equals, leave it as a fraction, guys, 100 over 3. When you do something like this, x equals 33.3, you're already rounding. That's not as accurate as this right here. Sure, it's really this right there, but why would you want to do that? You can't really type that as easily into, say, an answer somewhere to submit it. So what's better is just leaving it 100 over 3. Don't make it a mixed number. Don't make it a decimal. A reduced fraction is best. Got it? So that's our answer. That is all it takes. Now, what if you wanted to use product property? You were distracted by that, and now you are here. Okay? So I'm just going to put that somewhere on the side. That's something else. And let's just draw that arrow. Okay. And that was still equals 2. Okay, I'm going to subtract log 3 from both sides. That's going to give me log x equals 2 minus the log of 3. Now this is all a number. There's no variables here, as much as it's weird looking because there's the word log in the middle of it. It's just the number, okay? Log 3 is something you could potentially punch into a calculator. Don't do that. We're not doing that right now. That's fine. Now, I still have an invisible 10. My base is 10. This whole thing in the parentheses is my y, and x is the x from this right over here. Rewriting it, 10 raised to the 2 minus log of 3 equals x. That's not wrong, but it wasn't necessary. It's a little messier looking. I think that is a little bit more, a little scarier looking, you know? So no need to do anything that way. All right? That's not wrong. This is better. We like this a little bit more. Next, log, in this next example, instead of having something with the x, it's sort of like what I showed you here. So this kind of relates there. Could you take that 4 and put it back in the exponent? You could. Do you have to? No. Because it's in front of log, not in the log. It's like being in front of a square root and not in the square root. We could just divide both sides by 4. Log of x equals 1. All right, home stretch. We're finishing up. We're doing great. We have to get x alone. We have log base b of x equals y. But what's the b value? What is the base of this plain log? The base is 10. So I'm going to go from logarithmic form of a logarithm to exponential form of a logarithm. So that's important. It's not an exponential equation in the same way that we were graphing exponential functions. This is exponential form, still is an exponential equation, sure, of a logarithm. The x and y's are swapped around. So some of you draw the little looping arrows that I drew. That's fine. 10 to the 1 equals x. And that's it. We're done. Because what's 10 to the first power? Some people are writing 100 and 0 and 1. 10 to the first, anything to the first is itself. So x equals 10. And that was it. Okay? Because some of you are doing way more intense stuff here. Now for this one, we're going to take log base what of both sides? We're going to take log base 7 of both sides. Because the 7 is the base of the exponential. Don't switch the numbers. Log base 7 of 7 to the n. And log base 7 of 12. Now, here's the original problem. 7 to the n and 12. We jumped in and took log base 7 of each side. Those are gone. What's left? N. On the right, that's it. Log base 7, 12. Don't even touch it. Some of you did more with that. No. You are good. Don't even bother. The only way I would go further is if 7 to a power was equal to 12. It's not. If that were a 49, if that was 343, 1 over 7, 1 over 49, then I would do more. I'm not going to do more than that. You're finished, okay? Here, I have 4 to a power. My exponential is already isolated, okay? I already have something to a power. That means I can go right ahead and take log of both sides. So I'm going to take log base 4. A big thing I was seeing is people using log base 2. No need. I never changed up the base of the logarithm. It was always based, based. It was always reflective of whatever the base of the exponential expression was. You shouldn't be using a different number, okay? I never showed you that. Let's be consistent here. So I'm taking log base 4 of each side. This is 4 to the 3n, and this is 5. Log base 4 and 4 cross out. 3n equals log base 4 of 5. Now, the next step we can go about in 2 different ways. One way you can think of it is we're going to divide both sides by 3. I'm writing it like a little funny here. Maybe I should rewrite the problem. 3n log base 4 of 5. If I do that way, I get n equals, my numerator is log base 4 of 5. The bottom is 3. Another way I could do it, instead of dividing both sides by 3, would be multiply both sides by 1/3. Three and 1/3 reduce down to a 1, and we're left with only n equals 1/3 is just a number out front. That's my coefficient, 1/3 log base 4 of 5. So both of these answers are the exact same thing, just one is written as being over 3 and the other is written with a 1/3 in front. They're identical, so either answer is acceptable. Again, I did not use a log base 2. If that is something that you did when you submitted numbers 9 through 16 for this second time around, I suggest you go back and change that. I know you might not be wrong, but that is not what I showed you, and you're really going based off of either a tutor, a friend, the internet, or just copying from somewhere. Even the work you showed, for those of you who did log base 2, and you jumped to the next step, you're not even showing the step that got you there. So I'm not quite sure you understand what it is you're doing. That's why I'm reassigning these questions. Okay, let's look at the bottom two. This one right over here, it's already written in log base b, again, we just happen to have 10, of x equals y. And my base is just 10. I can rewrite that, 10 to the third. Some of you are a little confused on what 10 to the third is, so we could use a little practice with that, I believe. 10 to the third equals 3x minus 2. 10 to the third power is a 1 with 3 zeros. Anytime you have 10 to a power, the power tells you how many zeros you have when we're dealing with a positive exponent, okay? 10 to the 1 is a 1 with 1 zero. 10 to the second is a 1 with 2 zeros, and so on. So 10 to the third is 1,000. Comma goes every 3 numbers from the right. 3x minus 2. Another mistake I saw here is when you guys were adding 2 to the other side, people don't show their work, and you guys are all, well, not all of you, but a good amount of you are writing down 998. Do you see the error? You're very distracted because you're not showing work and you're looking at the minus 2 and you're just writing, oh, I'm super confident, 3x, and you're getting 998. Show your work, okay? I majored in math. I've been teaching math for many years, and I write my steps. So when we add 2 to both sides, we get 1,002 equals 3x. Divide both sides by 3. As I was writing down the 1,002, I was wondering, is this divisible by 3? And what I thought about in my head, and I don't know, maybe some of you thought of the same thing, I thought 999 is divisible by 3 because 9 is divisible by 3. 999 plus 3 is 1,002. So if 999 divided by 3 is 333, that was in my brain, that means 1,002 divided by 3 is going to be 334. So final answer is 334 equals x, or I'll write the x over here, x equals 334. If we look back, I should have been doing it on the earlier examples, but I knew that those domains were all positive numbers. My answers were positive. If I check it with my domain, you're only allowed, think of your domain as this. With log, we can only take log of positive numbers. So take whatever you're taking the log of, which in this case is 3x minus 2, set it greater than 0. Solve for x, and that will give you your domain. So 3x is greater than 2, and then x has to be greater than 2/3. That's my domain. I could put it on a number line. I could put it into interval notation. Is 334 greater than 2/3? You bet your sweet butt it is, so we're done. Number 8, I saw solved 2 different ways, and that's totally fine. And I will show you the way I think is a little neater. And then I will show you another option. So option 1. First thing I'm going to do is I'm going to put this 2 away up in the exponent. I'm going to clean and compact this into a single log. Once I have the left as a single logarithm, I will use that, do a little flipperoo, change it to exponential form, and go from there. So log of x to the second, that's power property, minus log 5 equals negative 2. Subtraction between 2 logs means we can use quotient property. Quotient property takes the 2 things we have, we're taking log of, and makes them our numerator and denominator. So we'll have an x squared over 5. Over here, log is base 10 again, and we're ready to switch this around. 10 to the negative 2 equals x squared over 5. 10 to the negative 2 equals x squared over 5. Now, I spent a while going over properties of exponents with you guys. We've done it all year long, lots of practice. 10 to the negative 2 is 1 over 100. Why is it that? It's really 1 over 10 to the positive second power. So if you need to write this step before you write this step, okay, that's fine. Now, that equals, I'm not going to write this step just because I'm going to save a little space, but you're allowed. Now I'm trying to get x alone. I'm going to multiply both sides by 5. These reduce down to 1. 5 over 100 reduces. 5 over 100 reduces to how much? 1 over 20. So 1 over 20 equals x squared. Now we need to take the square root of both sides. X equals, again, I just flip-flop my left, right. Square root of 1 is 1 over, I also should use the plus minus in front because I'm taking the square root myself, but we're going to end up cleaning up our domain. What's the square root of 20? We're taking the square root of both sides right now, okay? Taking the square root of both sides. What's the square root of 20? Well, if I go up here and make a little practice, 20 is 2 times 10, and 10 is 2 times 5. 2 times 2 is 4. That's a perfect square. Square root of 4 is 2. That comes out when we get 2 square root 5. So plus minus 1 over 2 square root 5. We have one thing left to do. That thing we have to do is rationalize our denominator. So I'm going to multiply on top and bottom by radical 5. 1 times radical 5 is radical 5. So x equals plus minus radical 5 to radical 5 times radical 5. Radical 5 times radical 5 is 5 times 2 is 10. The domain, whenever you have just plain log x in your problem, is all positive numbers. So the plus minus is not necessary. We only need plus because it's only the positive answers. So if I just want to throw in the step I did in a different color, I multiplied on top and bottom by radical 5 when I rationalized my denominator. Square root of 1, I got 1. Square root of 20, I did up here. And I got 2 radical 5. So a little star, so you know to look over there. We'll keep practicing this. This was a little squeeze just because I wanted to show you the other option. So the other option, some people, they just added log 5 to the other side, and that's legit. You can do that. So we'll have 2 log x equals negative 2 plus log 5. Divide both sides by 2. Log x equals. Now you can write the whole thing over 2, or you can put a 1/2 in front of parentheses. They are equivalent. Now, I know this is big and weird and strange to do, but I can change this to b to the y equals x. That means 10 raised to the negative 2 plus log 5 all over 2 power equals x. So that works. It's fine. It's a little weird, but I think this way in the long run will end up making more sense to you in your head. These are actually equivalent. If you put them in the calculator, they're equal. So that was me breaking down 1 through 8 for you. Your next assignment was to do 9 through 16, and I'm going to make a separate video going over that. So what log base should you be using for this? Just log base 5. For 20, don't break down the 20 in your answer. I saw some of you were like, oh, it's 4 times 5, and 4 is 2 to the second. No need, okay? I think that's great and all, but you don't need to do that, okay? Leave it as a 20. Makes your life more difficult if you do this. Which other things did I see? Oh, numbers 13 and 14. What did you guys do strange? Well, don't use log base 2. I never did that. I didn't show you that. I don't want you to do that. Use log base 8 and use log base 4 for these problems. You might need to isolate your base to a power first, but don't use log base 2, okay? Here, this one should be familiar. It should remind you of the lesson we did first this week where we did solving without log, and we ended up factoring. So you should have some factoring. You're going to want to check your domain because you might not have both answers work, but I think you can handle that there. All right. So that was just some pointers for these. If you're still taking ln of both sides, I'm not going to mark it right. Okay. Please go fix your homework based on what we've been doing. Use the methods and strategies you've been taught because that's what you're being evaluated on. I hope that this helped you, and I hope you're able to do a really good job on this homework page here, numbers 9 through 16, and you're able to do them the way intended. Have a great day.